Hello, and welcome to this webinar sponsored by APG, Equipment Reliability Programs Making RCM Work for You, with Mike Schultz, Vice President of Solutions at APG. My name is Andrea Hauser, and I'm the Managing Editor for Energy Tech Magazine. I'll be your moderator today. Reliability-Centered Maintenance, or RCM, is an essential tool when developing maintenance programs for industrial equipment, but it might not be the most cost-effective solution for every part of the plant. Sometimes a variant of the RCM methodology might be more useful. This webinar will explain the RCM methodology, its variants, and how to decide the right process for your plant. Mike Schultz is the Vice President of Solutions at APG and has worked in the maintenance and reliability fields for more than 30 years. He has extensive CMMS and reliability software experience and is a respected and well-known expert in RCM. He has trained and mentored hundreds of people in RCM, has delivered RCM practitioner training for the Aladon network, and instruction on the PASS 55 framework. The presentation will last approximately 45 minutes and will be followed by a Q&A session. Mike, please begin.
Good afternoon, everyone. Thank you for that introduction, Andrea. Yes, I'm looking forward to spending the next 45 minutes or so going over RCM, broad overview. And I represent APG. We are reliability and maintenance experts and actually the largest group of RCM2 practitioners in the world. We've been involved principally in industries in power generation, transmission distribution, oil and gas, and municipal water and wastewater management. This morning's presentation will deal with the concepts around RCM, and I'd like to start first by discussing really why equipment reliability itself is fairly important. It's our view that at the end of the day, a customer is really interested in principally a few things. They want a quality product, certainly in the case of power industry, reasonably stable voltages and supplies. They're looking for that product at a reasonable price. Delivery in many cases, certainly industry specific, can be critically important, and the power industry, without a doubt, you folks do a heck of a job to make sure that service is always provided. And lastly, they are often looking for service in the form of good customer service, good relationship between the customer and the service provider. From an organizational perspective, then, we in industry, looking at it from an equipment perspective especially, achieve those organizational objectives by making sure that our equipment remains safe, stable. It's not injuring immediate stakeholders, employees within a plant, and certainly people outside of the plant organization, that the operation of that equipment is environmentally safe, not resulting in damage to the environment anyway. And to deliver the customer what the customer wants, we adhere or put in place a number of initiatives, maintenance initiatives in this case, that ensure a high quality product, enough throughput to meet the delivery requirement, and simultaneously a cost model that ensures, where there's a profit center involved, that the organization itself is making money. Moving down this chain a little, that's achieved at an equipment level by ensuring that the instantaneous capability of those pieces of equipment can meet those organizational objectives. That's done principally through reliability practices, maintenance programs, maintenance tasks that ensure that that capability continues to deliver those objectives. Interestingly, operating teams have an impact on that as well. They, in many cases, are performing some of those maintenance routines and therefore need to be involved and need to understand their impact on the maintenance efforts that are performed on that equipment, and simultaneously their own actions can directly impact the organizational objectives. Lastly, process technology has a role to play as well. In cases where instantaneous capability does not meet the organizational objectives through incapable design, process technology can step in and perform or suggest modifications and redesigns to bring that equipment back up to a stable state. The big question is, where are those appropriate? Oftentimes we'll see companies that perhaps focus too much on an upgrade, and in fact they have an inherent tremendous amount of capability built within their plant already. Just poor reliability practices result in poor efficiencies. From a maintenance practice perspective, we suggest that there is, in all cases, some level of base work. This could be referred to as the right work at the right time. This is the minimum amount of effort that's necessary to achieve those organizational objectives. Beyond that, there is always some level of non-value added work. This work takes the role of too much or too soon. These are maintenance tasks that are performed too often. Frequency is too short. In other cases, it may result in inappropriate maintenance tasks, change out or overhauls when in fact they're not managing an effective failure mode and resulting in unnecessary parts, labor, and intrusive action on the equipment itself. Beyond that, there is a level of reactive work in all organizations. Reactive work takes place because too little has been done, or in some cases too late. The tasks themselves are not effective. The frequency on those tasks is too long, and we missed that opportunity to intervene before failure took place. These have the highest dollar impact on the organization and almost always result in some form of unavailability or downtime, which impacts those objectives. Typically, the best-in-class program, unrealistic to believe that we would ever achieve 100% base work, so there is some level of reactivity and non-value embedded even in a world-class program, but the goal would be to move that base work to an 80% level. What we've found over the years is many organizations are in fact inverted in this view. A very small portion of base work being executed, a substantial portion of non-value added work, and a tremendously high amount of reactive work. The goal of the RCM program, or Reliability Centered Maintenance itself as a tool, is to make that conversion, from 20% to 80% by identifying where the opportunities lie and put in place programs that are going to result in the right work at the right time. Now, not sounding like it's easy, because it isn't. In fact, this requires a significant effort in time and resources, certainly from an RCM perspective, a very significant effort. It's not always easy to pull people away from their regular jobs. Sometimes the effort is doubled up because previous RCM attempts have failed, and there's a high degree of prejudice or feelings of, I've been through this before and it didn't work. We have seen instances where we produce optimal maintenance programs, but is that really what you need right now? The RCM effort is significant and would take a number of years to move through a large plant. Perhaps there's other approaches that are going to provide return earlier. And never or rarely does one size fit all. So today's webinar really is going to now broad brush a bit on what RCM is at an overview level. It has been around for quite some time, probably a vast majority of people, since you're interested in improving reliability by the very nature of signing into this webinar. You probably have some level of knowledge on what RCM is. So I'll touch on that briefly. Then I want to spend some time talking about variants of RCM, the different variant practices that have been developed and can be run in parallel to an RCM effort. There are, of course, common pitfalls with everything we do, and then we'll spend a little bit of time talking about where we can get started and what some of the keys to success are. Reliability-centered maintenance, without a doubt, an absolute proven process. RCM is the acronym for Reliability-Centered Maintenance, and it was born out of commercial aviation in the 1960s and 70s. A very extensive study took place. I'd like to give credit to the two gentlemen who led up the project, Stan Nolan and Howard Heap, and they did a great deal of study on commercial airplanes, in which case the failures are measured in crashes, and as a result of that study developed both a process and a series of concepts in how an equipment program should be developed. Other industries have tapped into the success of RCM since the 1980s, roughly. Some of the principal industries that have done so have been the U.S. military, specifically U.S. Air Force and Navy, And we've seen instances where power generation, specifically or typically in the nuclear area, have used RCM. And admittedly, to varying degrees of success. So that's a part of what today's webinar is to discuss. Also want to touch briefly on the fact that RCM as a process is described very effectively in the SAE, the Society of Automotive Engineers Standard JA 1011 and 1012, with the advent of a number of varying processes since the original work was put in place. There was some concern about what a true RCM process is. And so the SAE took up the task of looking into that and documenting what steps are required to adhere to the true values of a traditional reliability-centered maintenance analysis. So on that note, let's talk briefly about RCM. I think of RCM in two ways. The first way I think of RCM is as described here, the process that's used to determine what must be done to make sure that those physical assets that you're maintaining continue to do what the users, principally the operating teams, want them to do. Of course, this is all contingent on how you're using it today. That is the tool, the term I use. That's the tool of RCM to speak to a maintenance analogy. RCM is something else as well, though. RCM is a concept. It's a series of fundamental principles around which the tool is framed. I'm going to talk to those fundamental principles shortly, but I want you to bear that in mind as we go through this discussion. In this instance, though, I'm going to refer to the tool. The tool that was developed, the RCM2 process, outlines quite clearly that there are 7 detailed questions that need to be answered in that order. And those questions will step a team through a detailed examination of a system or subsystem, and by answering those questions effectively, they will come to an answer or a conclusion which delivers that minimum amount of work that must be done, that day's work as we described in the previous slide. Those tools deal first with the functionality of equipment and details what the standards of performance need to be in terms of performance indicators, the actual definition of what failure is, referred to as a functional failure, causes and effects, standard FMEA approach. And then from there, a comprehensive review of consequence of failure and how that failure matters, followed by options available to us to predict or prevent failure or other options when prediction and prevention aren't available. The RCM analysis approach is built around a facilitated session involving key stakeholders who have extensive knowledge and understanding of the equipment, led by an experienced facilitator. And therein leads to one of the first areas of concern or where difficulties have arisen. Without an experienced facilitator guiding and leading the group, it's very easy to go off the rails, and it's very easy for teams to become frustrated at the process. In the end, facilitation is how RCMs are performed. It's all about what this process delivers. And in many cases, we would apply this RCM technique to poorly understood equipment, new equipment where we don't have much information in place, critical equipment, equipment that's considered very serious in the context of this facility. It will help us deliver a very robust proactive maintenance program by analyzing at a function level how this system should be operating and what those key standards of performance are. This will deliver that minimum amount of work. It will help to maintain that system performance in order to meet those organizational expectations, and will also provide the group with a very solid understanding of the equipment, how it behaves, how it should be maintained across the spectrum of maintenance and operating groups. However, it is certainly time and resource extensive and requires a pretty serious effort to deliver the people necessary to make it a success. The results of this analysis are the most optimal program, a very heavy emphasis on condition monitoring, in many cases displacing incorrect preventive tasks, overhauls and rebuilds, and replacing them with condition techniques that will outline when a repair is actually required with some level of advanced indication. Emphasis on functional testing, a very deep emphasis on the need to understand principally your protective systems to make sure that they're working properly. And a blend of run to failure and redesign. The fact that in many cases, even if you can perform a maintenance task, it might not be the most cost-effective answer to the problems that you're encountering. The knowledge of your equipment dramatically improves, and in many cases, safety or environmental issues are uncovered during those analysis sessions and actions put in place to mitigate or eliminate them completely. We would use an RCM analysis technique in areas where there is a lack of understanding of the function of the equipment, areas where the equipment is performing and key performance standards are not necessarily fully understood, principally by the maintenance groups, but also by the operating teams. And therefore, the program is designed to flush out those key performance standards. Greenfield sites and new installations are a good example of that, especially when we're dealing with newer equipment that the teams have little experience in. And certainly in areas where there is a high criticality associated with that equipment. This is the most robust and extensive tool and would ensure that we have a complete and thorough understanding of the failures and appropriate mitigations. That said, this is probably ideal for 5, 10, perhaps as much as 15% in some cases of your asset base. It wasn't that long ago that we thought differently, that we thought, in fact, this is the tool for all equipment, and it has become clear over the years as evolution takes place in any industry or process that is not the case. And certainly anybody who embarked on some of this work a number of years ago, perhaps 5, 10, 15 years ago, would have been told all of your equipment, it would have seemed daunting, overwhelming, literally impossible. Our belief now is that that's not true. However, it doesn't mean that the other 85 or 90% of your equipment requires no form of analysis at all. So the question then is, before we move into the other processes, if RCM is right for every job, do you have situations at your plant where there is significant tribal knowledge, where your teams have quite a bit of knowledge on failures, how the plant is supposed to operate, what those key standards of performance are? Do you have detailed condition monitoring programs, but you're concerned about cost, the associated costs of those programs themselves, and perhaps even their effectiveness? You have situations where there are literally identical or very, very similar assets, rows of boilers, rows of generators lined up beside each other, all operating in virtually identical conditions. Or perhaps there's a situation, I would expect probably for the vast majority of you not the case, but there are folks in industry in various environments where they are truly just interested in stopping the bleeding, where they are literally jumping from one reactive event to the other each day, and those are often displacing your opportunity to perform proactive tasks, which fundamentally become the next day's or the next week's reactive failure. So there are different situations in plants, different circumstances, and it does seem surprising that one tool would be able to fix them all realistically. So the suggestion here is that's not the case. If you had a toolbox and opened it up, I'm quite certain that your toolbox, like mine, holds a number of tools. One of the fundamental questions, though, is based on those tools. Which tool do I select? So I'm going to provide a very simple example of a simple quadrant diagram that describes some of these variant RCM strategies and what would be some logic behind their selection. On the x-axis, I'm going to describe things in terms of maintenance program definition. How well do you know the maintenance program that's in place? Can you put your hands on it? If you asked someone or you asked yourself to go out and perhaps print it from a CMS or extract it from a series of books, how easily could that be done? How well is it defined or discernible? On the y-axis, I would like you to think about things in the context of current asset performance. How well is the equipment in perhaps a system running? And we're going to come back to those organizational objectives in this context. We're going to talk about What is the throughput or availability of that equipment? What's the quality of the product it's producing? What is its impact, typically on safety or environmental integrity? And along with those effectiveness measures, I also want you to think about current asset performance in the context of cost. Is there a high cost, maintenance cost, associated with this equipment, or is maintenance cost where you want it to be? We'll begin our discussion in the top left-hand corner. We'll talk about what we refer to in APG as an asset care development process. This would be appropriate in instances where we are achieving a high degree of performance. Our costs are excellent, they're under control or within budget, and we also see very high effectiveness with this equipment. The quality is outstanding, the throughput is at great levels, and we're not seeing significant safety or environmental issues with this equipment, both internal and outside the plant. However, there is very little evidence showing exactly how this is being done, how maintenance is being performed to achieve these levels of result or capability. That should be of concern, because what that means is, assuming that everyone agrees that equipment does not fix itself fundamentally, that means that people are doing tasks and those tasks are not documented. There's also the potential that those tasks have not been vetted effectively. So in that case, we would look to pulling that excellent information out from individuals who are performing this good work, running it through a quick vetting process, verifying that it is technically sound, and then documenting it. Further down in the bottom right-hand corner, we would see examples of a very well-defined maintenance program, a program that can be extracted and understood quite obviously, either on paper or on the computer. However, as detailed as it is not effective. This particular program, being executed diligently, is not resulting in high asset performance. Therefore, the issue here is that there must be something wrong with the program. It could be frequencies. It could be that it's not managing the right tasks. It could be the tasks themselves are intrusive and resulting in issues. So rather than throwing the baby out with the bathwater, the proposal here would be to have a look at that detailed plan and understand the program itself and make modifications. Another instance could be the sort of the worst case, if you will, which would be terrible performance and really no program to speak of. And if people are operating down in this environment, and some are, the idea of approaching them with a formal facilitated process is just out of the question. Resource intensive, taking people off the shop floor. Meanwhile, these folks are dealing with daily firefighting, and it's not even within the realm of possibility to do that sort of thing. So we would apply a basic care approach, understanding that it is a first pass and would probably need to be vetted later. RCM could fit up in the top right-hand corner, where there are still some efficiency gains, still some gaps in the program, still areas for asset performance improvement, and where we could then squeeze those last through a few drops of juice out of the fruit. So fundamentally, we're proposing that there are a number of variant options available: basic care, asset care development, maintenance program optimization, and these are at the end of the day modifications on the SAE compliant RCM process. I can't overemphasize the importance of retaining the core concepts. I told you when we got started about RCM that it is a combination of a tool, but also of a philosophy, also of a thought process, a series of rules and axioms. Those are retained within the basic care, the ACD, and the MPO process, which helps to make them and continue to make them a technically based application. Yes, less rigor, certainly in documentation than RCM, but it provides an opportunity to do things faster and reduce that demand on resources, while still fundamentally retaining the concepts and fundamentals of RCM. So we refer to this as a technically based approach, and what that means is that to apply a variant strategy with a technical basis around an RCM framework, we need to be challenging tasks for worth. The worth can be evaluated both in cost, but can also be evaluated in risk reduction when dealing with safety in the environment. We need to align the cause of failure to the task, and we need to ensure that the intervals are based on technically valid principles. Of course, there's an effort put into the task definition to provide detailed acceptance criteria and an example or a suggestion of what the corrective action should be in the case of functional tests or condition-based approaches. So let's deal with these variant processes on that context of a technical basis. The basic care approach is really applying maintenance best practices, but in a component level of detail. No insight or time is spent on developing an understanding of how the equipment is operated. Don't really want to apply this where there's a detailed maintenance program in place, and another reason would be that the idea of using one of the other variants or an RCM is not in the realm of possibility. There are many industry available FME templates that we could apply, heavy focus on cleaning, lubrication, inspection, with the desire to pluck that low-hanging fruit and worry about refinement later. Really put in place just a basic program. Downside, the risk side, is it doesn't consider operating context and will probably result in too much maintenance out of the box. Principal reason here is that we're really taking that machine template, a template for a motor, a pump and motor assembly as shown in this example, and then finding all pumps and motors of a similar nature throughout the facility and applying the template directly. The output would, in all likelihood, look something like this. This could be an example of a centrifugal pump basic template. We've got motor bearings that require lubrication. We'll provide some indication in the reporting of frequency. In this instance, 3 months, 30 minutes. The mechanic should do it. We have to have a look at the pump motor fan filter, replace it every 6 months, 45 minutes, and fundamentally apply this template logic to those centrifugal pumps as identified within the plant. However, that is done regardless of operating context. I mentioned to you that it may result in over-maintaining. At the outset, it looks like a very logical approach. It suggests that if we have 3 identical pump motor assemblies, A, B, and C, they're all operating the same pressure, the same head, the same flow. They're pumping the same material in virtually the same configuration. Now, fundamental thinking would be that they would have identical maintenance programs. Basic care would apply an identical maintenance program. However, when we bring operating context into the mix and we begin to think of these pumps in a slightly different light, what if I changed just one thing in this example? What if I began to look at these pumps in separate systems, in one case operating on a standalone basis, and in another case operating in a duty standby configuration? Just a minor change in operating context. What a dramatic effect that can have on the PM program. Because in the first case, were pump A to fail, it would affect production. It would affect the ability to produce. And in the case of pumps B and C in this installation, if pump B failed, there is an opportunity to either auto start or manually start in time without consequence pump C, and then simply repair B. In the case of the standby pump C, it's a little different. When B is operating, there's virtually no understanding of the capability of pump C. So they have certainly a big impact were it to fail and B also failed. Therefore, in the case of a standalone system, I would have a direct adverse effect on operational capability as a result of the failure of that pump. That would justify a blend of preventive and predictive maintenance tasks, perhaps not unlike the template that was revealed on the previous slide. That said, in the case of our duty pump, the impact is really non-operational. It doesn't affect the manufacturing process or capability. It doesn't affect the ability to generate power in this instance, in the case of this webinar. And therefore, you'd have to really question what return on investment we're getting from a predictive especially, but also some preventive techniques. There will be some that would still be retained. Certainly no suggestion that we'll stop lubricating the bearings in the motor. But other things that you saw on that slide, like flow and pressure checks and perhaps vibration analysis, would no longer be justified. So a different program for Pump B. And then Pump C is radically different. At the end of the day, when Pump C fails, nobody knows it's failed until such time as the duty pump fails. Therefore, we could be looking to a functional test, a completely different program. So operating context can have a dramatic effect, and is the risk fundamentally of applying a pure basic care approach based on templates to your equipment without bringing that into bear. So it would be possible then, after a quick pass of basic care, that it would be time to go back and examine now that developed maintenance program and optimize it, again applying the RCM concepts against it. We would look at the maintenance program, if it's well designed, but we're not necessarily receiving the results we want. And as I stated previously, in the case of a basic care approach, those results could be something like high cost or unnecessary maintenance. And really look at what failure modes are taking place, validate their worth or their value, validate, in fact, that they are the technically correct task. Again, in the previous slide, perhaps while it's correct to perform a particular task, it's not going to cause the return or result in the return we're looking for. In other cases, it may be simple adjustments of the tasks themselves, converting them from preventive to predictive, optimizing frequencies, looking at different technologies. The benefit here is you really don't have to start from scratch. You've got a PM program in place. You really just want to get it working better. So let's make that our starting point. Risk side, the downside, it doesn't force the users to have a detailed understanding of system functionality. It is possible, in this case, that something could be missed, since it's based on the existing PM program only. So in this instance, again, with our pumping analogy carrying on, we see this cooling water pumping system. We have a duty and we have a standby pump. And the program may, at the outset, look like this. This is not uncommon. We visit many installations where we would see a duty pump with a pressure relief valve if it's a positive displacement system on a 6-month frequency, and the teams indicate that there is a vibration analysis task taking place. Are these tasks really the right ones? Are they the ones that are important and necessary to keep the overall system functioning? Remember, the system includes the standby as well. Is there anything missing? Potentially there is. So the PM program then, after applying an MPO analysis, would now introduce the idea of a failure mode. The question why is asked to the teams. Why are you performing a duty pump pressure relief valve test? The response is in the form of an effect which identifies a safety consequence if such a task is not performed, and it's fundamentally acting on or working on the failure mode, duty pump pressure relief valve failed closed. So the task is verified as being effective, and the frequency perhaps is adjusted based again on those RCM principles that are used to determine a technically based frequency. In the case of the vibration analysis, when the question why is asked, the response is because the duty pump motor bearings can wear. However, a quick view through failure effect identifies that there is really no consequence of this event, and the most cost-effective solution is actually no scheduled maintenance. However, this is under the context that the standby will be available and working when it's required. Therefore, a couple new tasks would be added that include a standby pump motor assembly failure finding task and the standby pump pressure relief valve test. Again, just a simple example of what the input and output might look like. From an asset care development approach perspective, really this again is acting on pieces of equipment that are performing at a fairly high level, and what we want to do is base the program on that user's knowledge, on that tribal knowledge, and not necessarily focus so heavy on RCM to extract that information. We would apply this where there's no formal maintenance program in place, but we are getting excellent results, and that is on the presumption that we have a very thorough and complete understanding of the functions of that equipment and the required performance standards for it. It is performed ad hoc. What I mean by that is we don't need comprehensive formal facilitated sessions. The facilitator can visit the technician at his desk and then pull that information out. We'll provide a link to failure modes and, again, verify worth and validity of tasks. By capturing that tribal knowledge, we'll have the opportunity to formalize and verify the program. On the downside, once again, it doesn't force system understanding from the participants on the presumption that the system is already well understood, and the proof is in the results that are being received. So a before and after state for an asset care development program, there wouldn't be a before. Once again, we're talking about a program that is not easily discernible, not easily extracted. It is fundamentally in the form of tribal knowledge. Should be of concern to anybody in this environment, because with an ongoing aging workforce, that's pretty much the case in a good part of the world these days. As these individuals leave, they will take that knowledge with them. Subsequently, we'll probably see a reduction in effectiveness. So the question beckons, what are those tasks that are being performed to keep that system functioning so successfully? And boy, I would sure like to get that information before those folks in that workforce, who are usually the senior folks, depart. So the questions would be asked, what exactly is being done? That's a starting point for an asset care development analysis. Let's talk about what's being done. What tasks are being performed? Well, the response could be, I checked the pressure relief valve. We would then translate or relate those back to the failure mode. I think you should be seeing a fairly common thread here, failure mode-based analysis in the case of all of the variants and RCM. That's how it maintains technical correctness in order to be able to refer to these as technically based programs. From that failure mode, we verify that this particular task is managing that failure mode effectively, and then once again identify a consequence and appropriate frequency. In other instances, to stay with the same theme, we had a bearing problem once, so now I change it every year. This is not uncommon, and it goes to show that even in a highly performing environment, there still may be some non-value added tasks in that grouping. Therefore, we would identify the mode, in this case, of being a duty pump bearing wearing, but in the case of the duty pump, it would still recommend the same no scheduled maintenance task. Other commentary on occasion is the standby pump doesn't run so much, so we don't do maintenance on it, or perhaps we're alternating it on a 50-50 frequency. So we would look to more optimal techniques to manage standby, which could result in a recommendation for a functional test of the assembly. Another advantage to the ACD method is, and this isn't the same as the basic care, is to apply a completed asset care development or reliability-centered maintenance analysis to other systems or subsystems with virtually identical configurations and operating context. It's not the same as the basic care approach because it operates at a system level of detail, as shown in the pictures, a series of cooling towers that are virtually identical one to the next. In this case, operating context comes into play. It is considered in the analysis, and as such, we are able to pull down the good work that was done previously in an RCM or an ACD and fly through a quick vetting session to verify that these particular failure modes are correct and pertinent in this operating environment, and verify that these tasks are the correct ones to manage and maintain that asset. As a result, certainly in installations where we see a number of identical devices side by side, that could be something like a generator room, spend some time up front analyzing generator number 1. Then apply a templating approach using an ACD method across the other 4, 5, 6, 7 machines. Now, I will admit up front that the quadrant diagram that we discussed earlier on is a bit of a simplistic approach to choosing the right strategy or choosing the right tool. It's never quite that simple. It is multidimensional. By example, if we look at this simple chart that we've produced, perhaps there's an instance where there's no PM program in place, basic care approach once again. But in other instances, we might see critical equipment coming into the mix and being discussed. And the fact that critical equipment, we could apply the multitude of processes to it. Didn't talk about criticality in the quadrant diagram, but it is certainly something that should be brought into the decision-making process, along with, as it shows in the bottom of the page, previous variant methods were unsuccessful. That could mean that we've tried some technique, we've tried a program optimization technique, and we're still not getting the level of reliability we want, or we pulled down the asset care development program, but it's not quite optimal. Usually means that we don't have a complete and thorough understanding of the functions of this equipment, and it would suggest that we need to escalate that particular analysis and vet it through an RCM process. So the correct tool for the correct job, not always incredibly simple. We at APG have spent some time putting great thought into both RCM as a tool and the variant methods we discussed, and put in a fairly robust decision logic that incorporates far more key factors and aids in correct tool selection. So on that note, dealing with some of the pitfalls, some of the areas where reliability initiatives have stumbled, especially areas where RCM has been applied. Probably one of the principal ones is in this area of an experienced facilitator. Facilitator has such an enormous influence on the output, an enormous influence on the attitude of the teams themselves, and without another way to say it, making the experience enjoyable as opposed to painful. The more experience that facilitator has, the faster the group can move through a large collection of equipment. And I can't overemphasize the fact that properly trained in the methodology as part of their regular job, they will do a far superior job. This is where we get into the challenge of the use of an external resource versus a competent internal resource. Lack of training is very critical. Without appropriate training and knowledge of the process itself, how to apply it, both for participants and for facilitators, there certainly is an opportunity then to start making inappropriate decisions. Wrong people, and sometimes the right people aren't available. Certainly, again, RCM would provide the most powerful output, but if you can't gain access to the folks and you've got options available to you based on the decision logic we discussed, then perhaps we need to look to different strategies to ensure that we don't stumble over the analysis phase itself. Long-term leadership commitment is key. Most programs that have been very successful are as a result of leadership, both middle and senior leadership support for a program, and then fundamentally for the implementation of the results of the reliability initiative. It really doesn't stop at the end of the analysis phase. There's a significant amount of effort still required in implementation, and then the teams themselves need to start doing that work to make it a real success. Therefore, an overall implementation plan is critical. Thoughts given to what should be done. As well, that robust methodology, make sure that it's applied consistently, make sure that it's the correct tool for the right job. So where do you start? Well, have a close look at the systems. Where are your high critical and risk equipment? So do you understand the criticality and risk associated with that equipment? What are your maintenance costs associated with that? Do you really know where your opportunities lie? How's the performance of that equipment? Have you got ways of measuring its output and its capability versus the organizational goals that are in place to meet customer demand? And understand the size and complexity of the systems and where there perhaps are some template opportunities because equipment is operated very similarly. Once a good thorough understanding of the system has taken place and the systems that you have in your asset base, then it becomes a method of running through those systems and making a tool selection. You're going to go through many of the things I've discussed already in a fair bit of detail, an exploration and extraction of the maintenance program? How detailed is it? How well is that equipment performing based on your equipment performance assessment? And where does that critical equipment lie? And lastly, how well is the equipment understood? Do we really know what the key performance standards are of this asset in this installation? So from a success perspective, I could sum it up in this manner. For an analysis to be successful, you really do need to apply the right tool. Understand the problem that you have in place. Follow some kind of methodology to select an appropriate tool. It really is not much different than that tool selection process at home when you open up the toolbox and you reach inside. What is your decision, logic, or thought process around what you put your hands on? Prioritize your systems. They don't all have to be done. It was suggested that perhaps 5 to 10% require the full-blown RCM method, but for the others, not all of them have to be analyzed, and you need to know where is the best place to start. Can't overemphasize again the importance of experienced and dedicated facilitators and a team that's committed to making a difference. Where I've seen this work very solidly is in areas where the team was devoted and behind the desire to make a change, and were appropriately trained so that they were able to assist and work through and to the correct decisions. Willy-nilly is never a good thing. The idea that we need to have a pretty solid implementation plan in place should be pretty obvious to everyone. That outlines the goals, the objectives, what is it we're going after, what do we expect to achieve, what are the time and effort resource requirements, which tool are we going to select on which system. It's just classic project management at that point. And with thorough and effective leadership commitment towards a project of this nature, it really is all up from there. So that's a round out of my discussion this afternoon, really talking again about reliability programs themselves and the RCM effort along with the variants that will help you achieve that high degree of reliability that you're looking for. At this point, I'll let it go back to Andrea, and we can perhaps open this up to some questions.
All right, great. Thanks, Mike. And we do have our first question from Todd. He asks, can you identify any electric utilities that have successfully implemented RCM? If there is, how long did it take for the organization to adopt the RCM program?
Specifically, I've heard of some work being done, Ontario Power Generation, many years ago. There's been some efforts taking place in Western Canada. The RCM effort was early adopted by, again, principally the nuclear side of the energy sector. And I think what happened was many of these folks got bound up in trying to apply the full-blown RCM effort, which is never an easy initiative, and implementation then became a struggle. We have had some opportunity to work with folks on the distribution side, very, very similar assets, certainly in the case of large transformers of a certain size. There's not just one, there's hundreds, potentially thousands. Large 240 kV breakers, once again, not just one or two, but many of them distributed across vast regions. And in that instance, where we've seen success with a utility in Western Canada was working with those folks and providing an RCM approach in this case, but with the view to making it a template or a shell which can then be applied as a base maintenance program to those large assets. And they saw a great deal of success and significant improvement in the reliability of that equipment. They also saw a significant reduction in the tasks that they were already performing. They were a little bit into the too much, too early mode, and we were able to detail that the failure did not progress that quickly and therefore did not require the PM to be executed that often.
Okay, great. And our next question is from Edward, and he says that the presentation has discussed improving the reactive work, but what are some guidelines for reducing the NVA work?
The non-value added work? The non-value added work is principally also reduced by looking at tasks that are of value but are perhaps being performed too often. Not unlike sort of the answer I just gave a minute ago. The PM that is perhaps performed weekly when in fact it doesn't need to be performed more often than monthly. That would be one example of a reduction in the non-value added effort, the too much too early. Another example of a reduction in non-value added is in the displacement of preventive actions, which are intrusive and only rarely technically appropriate, perhaps in not more than 10 to 15% of your asset base. It's not uncommon to see a facility that has a high degree of preventive tasks taking place, again, trying to be proactive and keep their equipment running. But in fact, a condition-based approach is both superior from a technical perspective and also cheaper. In many cases, oil analysis over years will prove to be a cheaper solution than oil changeout, and that will help to reduce the cost side of non-value added work.
Okay, now we have another question from Syed, and he is wondering, are you seeing new project development teams starting, including RCM and maintenance strategies as deliverable?
New project teams
that focus on RCM?
It's becoming quite common. We're hearing a lot of interest in receiving a lot of interest in these kinds of initiatives. We're seeing that take place of late, interestingly. We're talking of the last 3 to 5 years. We're seeing that take place really across the spectrum of our industries, oil and gas, power generation, and water wastewater. And it's being led by fairly senior levels. It's coming from the senior leadership of many of these companies. And what they're instituting or trying to institute is a reliability culture. We've seen examples of that on new installations, brand new equipment that is literally being built, commissioned, and installed, and the desire to apply an RCM-based approach, including the variants, to put in place a turnkey proactive maintenance program. In other cases, they are in situ assets, and the desire is to start to see the gap closed on their performance through reliability culture. And that includes the development and installation of an actual organization, quote, department, collection of reliability engineers, and clear goals and directives on where they need to get started. So I guess the short answer is yes.
Okay, great. And now Gary is wondering, what would be your advice on a high level for setting up a new PM system to implement RCM?
Oh, the implementation side requires, not unlike a few slides back, and if you don't mind, it's maybe a little bit easier to use this. From an implementation perspective, again, as the slide says, where do I start? You really do need to understand your asset base. You need to understand the criticality of the equipment that's in place and the risk that's being posed by it, where your costs are, where your performance issues are, understand size, complexity. Yeah, there's a little bit of work up front there, but this is really all about making sure that we're not sort of charging in to the building without understanding exactly why and where we're going. So some effort up front to understand the cost and the return on the investment of a reliability initiative. And then, now that we have available to us a number of tools, we can then begin to understand the existing program, and I doubt sincerely that anybody on this call doesn't have an existing maintenance program. But to what degree is it being effective? What are the costs associated with it? How are we managing the critical elements that we identified in our first suite? And what sort of tool could we use to close the gap where we think there's value in closing that gap? And my personal opinion, again, start slow, start easy, look to a couple training courses to change minds, look to a couple pilot initiatives where there's obvious return, and then let the process prove itself. I believe quite wholly that in a lot of cases the biggest issue associated with a reliability initiative isn't really the tool set, it's the change management required to get people thinking differently about how to both design programs and perform them.
Okay, great. And then Kim has what will probably be our last question. Is there some regulation or standards that the power generator supplier should follow from the perspective of RCM?
Not to my knowledge, or I'm not aware of any true standards, although we can certainly look to what SAE came up with, which was a good understanding or a standard related to what an RCM practice is. And then beyond that, we can start to see some of the emergence around the world related to reliability, or more appropriately, physical asset management. We can look to things like PAS 55, which came out of the British Standards Institute, publicly available specification 55, which helps to detail and outline really the key elements associated with a well-designed and defined asset management program, of which there's a component dealing with proactive work identification. Along with that, we're just on the crux now of seeing the release of an ISO standard related to physical asset management, again, based on the framework in PAS 55. ISO 55000 has been approved and adopted and is in sort of its last stages now before, my understanding is, before tentative or scheduled release round about spring of 2014. So those ones are more at a global level. There are others, certainly in oil and gas, there's a number of API standards and a few others that prescribe that at the very least you need to understand the criticality of your equipment, its effect on people, environment, production, and have in place formal work identification strategies to manage it.
Okay, great. Do we have time for one more question, Mike? Would that be all right? We have a question from Joseph. He's wondering, how can you apply RCM to a steam turbine? He says, you mentioned that you want to change components at the right time, but during steam turbine outages, many components are changed during the infrequent outages. So how can one reconcile trying to minimize maintenance costs associated with these changes that take advantage of when the equipment is opened?
So is this the point where I get to say I don't want the question? No, joking aside, that's actually an excellent question, and it is now a move away from utopian and theoretical ideas and a move towards practical approaches. Without a doubt, what has been asked here is an issue across many industries. Very large and complex reactors and vessels, and I had a steel background, blast furnaces. You don't peer inside one to have a look and see what's going on. So there you need a blend. There the RCM or variant methods will help define what those failure modes are, and in some instances we'll use some key indicators that will help us to decide when that steam turbine needs to be taken offline, and then also admit that when we're in there we are going to provide a number of comprehensive checks and change parts out appropriately, albeit it requires some intrusive nature, and it is the blend and mix of those two in a conscious effort through a formal analysis where you really find the best strategy.
All right, great. So that concludes today's webinar, Equipment Reliability Programs, Making RCM Work for You with Mike Schultz and APG. Please feel free to contact Mike with any additional questions you might have. And remember that the webinar will be available on Energy Tech's website, www.energytech.com, if you would like to watch it again or share it with colleagues. And if you've enjoyed today's webinar, sign up for our next presentation, Turbine Outage Optimization, on September 26th. Emails about registration for that webinar will begin going out tomorrow. Thank you for joining us.